Good afternoon, everyone, or morning, depending on where you're joining us from today. I'm Chris Brewer, Customer Development Manager for Lean Scheduling International. We're so glad that you've taken time out of your schedule to join us today for this webinar, Advanced Planning and Scheduling in ERP, what APS does that ERP does not. We're set for 1 hour today where we will talk and walk through Opcenter APS, formerly known as Preactor Advanced Planning and Scheduling, and show you how a multi-constraint finite capacity APS solution enhances your ERP by seamlessly integrating and addressing the otherwise existing planning and scheduling limitations of ERP scheduling modules. I'll be your moderator today. We're going to pause periodically, giving you all the opportunity to ask questions by using the Q&A button at the bottom of your screen or by sending a message through the chat window. Alongside me today is Hans Albright and Fraser Bonnett. Hans has a wealth of manufacturing and consulting experience. With 30 years of experience in manufacturing systems, Hans has spent the last 20 years both selling and implementing APS and ERP solutions. Before that time, he actually spent time as a production scheduler. So for you schedulers out there, he understands where you are and the challenges that you face every day. Hans now serves as our Vice President of Sales and Marketing here at LSI. And then there's Fraser Bonnett. There's a good chance that Fraser has more experience with Opcenter APS than anyone in North America. After serving 10 years in the United States Air Force as a program manager, followed by a number of years working with SCADA software at Raytheon, Fraser has spent the last 23 years delivering Opcenter APS. He was also one of the primary leaders in first bringing the Preactor product to the United States back in the late 90s. So between these two guys, I believe we're certainly covered in terms of knowledge and experience. But to make sure that we make good use of our time today, I'm going to go ahead and turn it over to Hans. So Hans, if you're ready, the floor is yours.
I am ready. Just a quick confirmation that you can hear me.
Yes, we can.
All right, awesome. Great. Well, first of all, thank you. I just add on to what Chris said today. Welcome. We're glad you joined us today. So I am going to start out with a agenda and what we have planned for this hour. A lot of material to cover. I'm going to try to keep my comments as brief as possible and turn it over to Fraser, who will do who'll actually show you the software. So I'm going to go through just by introducing to you some concepts. What is scheduling about? And then from there, move into, well, what is ERP planning scheduling? What can it do? And then we'll move into a discussion about APS, kind of breaking it down into planning and scheduling. Before we wrap up and turn it over to Fraser, I'll do a real quick intro to who we are, Lean Scheduling International, and then we'll give it over to Fraser. So that's the plan. So let's go ahead and get started. Starting with scheduling and what scheduling is. So I was looking for a statement that really captured at a very high level what scheduling is. And this is what I came up with: arranging, controlling, and optimizing work and workloads in a production or manufacturing process. And I think that's a pretty good description of the activities that go on. So while that's a good high-level description, there really is more to it than that, though. So what do people do with scheduling, and what is it used to accomplish? Allocating plant and machinery resources, planning human resources, mapping out production processes, and purchasing materials. So those are primary activities that go along with scheduling, and typically businesses will modify their production schedules in order to respond to large customer orders, to accommodate resource changes, increase overall production efficiency, and reduce costs. So this is a breakdown of, at its essence, what scheduling is. Now, a little bit of history to get going, like the tools that people have used. So here's the high-tech 1910, roughly, version of scheduling. And in case you can't read that down there, the text on this image is the planning department bulletin board at the Tabor Manufacturing Company, showing how under scientific management, the work for each man or each machine is mapped out in advance. Now, if you look at that, that may look familiar to some people, right? You've got a board, you've got jobs on the board, and it just should look fairly familiar. But this is 1910 technology, pretty old and outdated. So let's have a look at what do we see when we go into plants today. We go into a lot of different plants, show us how you're scheduling today. And this is what we often see. It's not much different. It's essentially the same thing. It's just more colorful. It's got magnets. You can write on it. It's essentially the same thing. And we see a lot of that, where people are using magnets and boards to move things around, to try to arrange them, to try to do their best job to basically do what I described as scheduling does. So looking forward at some innovations over time, and really this is probably the one thing that we see the most, and that is spreadsheet scheduling. So people do spreadsheet scheduling, people who have ERP systems, people who don't have it. But basically what you have is you've got column and row, and you've got tabs. And if you look along the bottom down here, you'll see, people will set up multiple tabs, maybe tabs to keep track of material information, resource information, tooling, employees, all that kind of stuff. It's really tricky when using spreadsheets, though, to keep track of multiple different operations and multiple different pieces of equipment, all starting with different times and having equipment and labor needs, etc. But yet, this is where most people are, is working with spreadsheets. And then, beyond that, ERP systems have realized they had a big hole in their systems, and that scheduling is just something that's being neglected. So a lot of ERP systems now have developed their own scheduling tools that are built right into the ERP. So I'm going to get into that in a moment. I just wanted to drop the visual here and keep it in line with this historical progression. But first, let's go on and talk a little bit more about scheduling. And just to put it in perspective, I like to do this exercise so that people can get a grip or get a grasp of how complex scheduling really can be. So looking at this, right, we've got 5 objects, and I'm going to say these 5 objects represent a machine, one machine in your plant. And this is a day's worth of work. Let's just say there's 5 jobs on this, and this is a day's worth of work. So looking at that, those jobs could be arranged any number of different ways. And so the question for you is, well, how many different combinations do you think, you could get from this? And that's a rhetorical. You don't need to try to answer. But basically, we're talking about 120 different combinations. So let's take this one step further and double that. So now we have 2 pieces of equipment, each with a day's worth of work. And now the 2 machines can share work. So these objects can be arranged on either machine in multiple different ways. So the question now is, how many combinations would you think you would have here? I mean, the last one is 120, maybe this is 240, something like that. Does that make sense? It actually comes to 14,400 different combinations. So now, in my example of each of these being a machine with a day's work on it, that's 1 day of work for 2 machines in a plant that may have hundreds of machines and may have months worth of work lined up. So now, as a scheduler, you've got to manage all that. How are you going to keep track of all of that complexity? You need to have some kind of a tool that's really going to help you with that and take you and enable you to do that. But yet, with all of this complexity, you have to figure it out. You've got some kind of a tool, and then add to that the reality of what happens after you've built this beautiful plan. You put this plan together, you put your heart and soul into it, and then boom, someone drops a rush order. There's quality issues, there's bad data, there's a breakdown, there's a flu epidemic. We all know about that in the last year. So these are the kind of things that will just blow your schedule to pieces. And I will tell you, as a former scheduler, dealing with all of that complexity, working so hard to put together the perfect plan, and then something comes in and screws it up, and it happens more often than not. And you end up feeling like you're just trying to push a rock uphill all day long, and it's just pushing back on you. And at times you just feel like it's a futile effort. It's very, very difficult. That's how it is to try to schedule when you don't have a good tool to do it. So let's go ahead now and get to the topic of the day. So I want to introduce some concepts, some ideas around ERP planning and scheduling, and then we'll move into APS. So with the ERP planning and scheduling, as I mentioned before, various ERP systems have kind of gotten on board and come up with their own tools. And I will say this for these ERP planning and scheduling tools: they may be user-friendly. They may have visibility to materials. they may update orders automatically. Orders may drop off when the schedule is completed. So these are the type of things that this may do for for you as someone who's scheduling with an ERP tool. So that's great. And the reality is, and I would be remiss if I didn't emphasize this, some companies really truly can get by with their ERP scheduling tools. Those are the companies who have really relatively simple scheduling to do, and often they're not very big operations. But however, let's talk about the tool set in ERP and what really makes it different and what distinguishes it from an APS system. So the ERP tools, typically there's an MRP, a material requirements planning element to it, and that's going to produce your production orders, your purchase orders. It's going to basically take the supply and demand and net that out. The problem is finite capacity, right? There's no real true finite capacity, and so what happens when MRP does its planning, it plans into time buckets. And so I put, so what after that? Like, well, what's the big deal about planning into time buckets? So what that basically means is it's not taking into account that you have a true finite capacity. So an example, you have a job that takes 2 weeks to complete. It's due next week. So MRP says, well, that's no problem. It takes 2 weeks to do it. So start a week ago. But that's not realistic. That doesn't help you. You need something that's going to help you face the reality of what you're dealing with, even if it's a message you don't want to hear. So honestly, best case that we typically see with most ERP systems is the ability to drag and drop on a Gantt chart, maybe some ability to connect operations. But most companies, even ones with these ERP tools at their disposal, 90% of the time, easily, ends up pushing that data into a spreadsheet to do their sequencing, their scheduling, and then work off of that spreadsheet. So most of these systems really only truly provide forward sequencing by a due date or some kind of a priority. As you can see, APS takes a much more holistic approach to scheduling than simply trying to line things up by their due date. And as far as simulation capabilities, like what's really happening on your shop floor, it's not that realistic. You're not getting a really true picture of what's happening. And then this last bullet point I emphasized, there is little or no consideration of these attributes. And if you're a scheduler, you know that these product attributes are the things that guide you, that you use to line things up for efficiency, to minimize setups and waste. So if you have product allergens in the food industry, you want to avoid cross-contamination. You want to minimize the cleanups between them. Same thing with chemical compounds in process manufacturing, colors, gauges, sizes, all different kinds of product attributes. Those are the things that must be considered when you're doing an efficient, realistic schedule. And the ERP planning and scheduling quite simply doesn't give you what you need to do that well. So this slide here really does kind of lay out the nuts and bolts differences between ERP planning and scheduling and what you're about to see then as we go forward. And I introduce you to the Opcenter APS tool. Okay, so Opcenter APS is a family of planning and scheduling software, and it's based on finite capacity scheduling engine. It ranges from really simple, basic resource run rate scheduling to really complex multi-constraint scheduling with advanced rules that have been designed to match the client's production and business environment really specifically. And the output is an accurate schedule that are basically taking into account your real-world limitations. So this is what you're going to see now as we go through the rest of this presentation. This is what Opcenter APS, what it is and what it can do for you. Looking at this slide, just a real quick bit of history. Opcenter APS used to be called Preactor, and it was rebranded a little over a year ago. It has been around a long, long time, and there are thousands and thousands of installations worldwide. And if you look at some of these logos, some very familiar logos across multiple different industries, It gives you an idea of the adoption rate among some pretty large companies, and also the flexibility of this product to be implemented in multiple different industries. Looking over on the right-hand side, then, the components, as I mentioned before, visual finite scheduling, visual long-term planning. So I want to break it down a little bit for you as to, well, what's the difference really between planning and scheduling, because those terms are often used interchangeably. So when we're talking about scheduling, when we're talking about planning, we are talking about what to make, when to make, how much, and where to make something, as well as the materials and the resources required to do so. You'll also find that planning is typically a longer range activity, months, even out years, as opposed to then scheduling, which is all about taking that plan and executing it. That's what scheduling is about. So that's where we're into the detail of the sequencing, keeping operations synchronized, taking into account all of the priorities, constraints, conflicts, monitoring and managing everything that's happening with that schedule. And as opposed to that long-term plan that we just discussed, this is down to the minute. This is short-term, it's real world, and it really takes into account the finest of the details that you need to execute your schedule. So another way to look at this, or a little bit more information on the planning, is that the way it's deployed typically is you've got a plan indicated by AP at the top level, which will do its planning into time buckets. Those buckets could be weeks, they could be months, they could be days, and we'll deliver that down to AS, Advanced Scheduling. Perhaps say at a plant level, you've got a schedule. We'll deliver it down to that level where it's then picked up and sequenced in the fine manner that I was just talking about. And the way this is commonly deployed in multi-site implementations is that you have this one planning module that will sit on top of multiple schedules. And what it does is it allows you to plan your capacity and load balance across all of your resources, whether those are at the plant level or whether you're down to a line level within a plant or series of plants. It allows you to do this balancing, this load capacity management well in advance of when you're actually going to be in production. And then the scheduling is Gantt chart scheduling. You're going to see a lot of that. So I just dropped in one screen to say, and this is the scheduling. So we're not going to see any planning today beyond what I've just talked to you about. That's pretty much it for planning. If you have any interest in learning more about that, please contact us. I can arrange to get you a demo, more information. I'd be happy to speak with you about that. So as far as Opcenter and the benefits, these are some numbers that when I started working with this, I didn't believe these numbers were real. I thought, that's nonsense. Come on, that seems a little bit overinflated. But yet, as I worked with this over the years and began to hear feedback from customers, these are the type of numbers that we're hearing from customers, that they are seeing improvements on this scale. So it's pretty significant. People realize tremendous benefits when they implement the Opcenter scheduling. Now, I've broken down as far as who needs advanced scheduling, who needs planning, and I just broke it down into a couple slides here. But basically, Basically, for planning, I apologize. For scheduling, this was, I just kind of did sort of an ask yourself, and you can kind of go through these bullet points yourself. But basically, if you're using spreadsheets, it takes multiple people to schedule your plant. That some kind of an expedited job can just create all kinds of disruption or even chaos in your plant. Do you know where your jobs are, right? Do you have machines or people standing around waiting for work, idle? How about your on-time performance? Is it less than your stretch goal? You should look at a scheduling tool to help you with that. Risk of cross-contamination in food or chemicals. Do you have too much time in setups? And do you know what that costs you to do that? And really, the people on the shop floor, do they know what they're going to do next? So if you have doubts about any of these, you should consider looking at Opcenter Advanced Scheduling. And then as far as planning goes, we dial this in even a little bit tighter. And the first bullet point I put on there is usually a really good starting point. And that is, do you make to stock as opposed to making to order primarily? If you're in the food, paper, chemical, other process industries, where you do commodity buying, that type of thing, maybe you have a forecast, but you still need to be able to plan your capacity, orders, and materials, seasonality, multiple capacity constraints, and needing the ability to balance your capacity between products and between plants or lines. Again, looking at this list, if something jumped out at you there, we should have a discussion about that you may be finding that you would benefit tremendously from planning. So whether it's planning or scheduling, the structure of the product is the same. And it basically is this, that there is a core code that is owned by Siemens Corporation that we never gets touched by partners. And around that is this modeling layer that allows you to take this product and fit it to your company, to the specific needs that you have and the specific problems that you're dealing with. And this is a toolbox that enables you to do that. And then again, as I mentioned, this core code, we can't touch it. Nobody can touch it except Siemens. They do that a couple times to a couple of upgrades per year. And upgrades are very, very simple with this. Because of this structure, upgrades are typically done in a couple hours or less. So it's a very clever design, and it has withstood the test of time. Okay, so along with this, we tend to get some questions as well, right? What data is required? How do you connect? Can it connect with other systems, or how do you do it? What about shop floor? Does that have anything to do with it? So basically, from a data standpoint, what's in your ERP is probably going to be good enough, although you want to be sure that you've got good, clean data. And what we're looking for is routings, resources, and the groupings, resource groups, bills of material, the work orders, and then your supply and demand that might be coming out of your MRP system. And then as far as connecting with other systems, really the bottom line here is that this is in a SQL database, and we have connected to so many different systems. For many ERPs, we already have pre-built connections, and if we don't, making those connections is not difficult. We can do it from spreadsheets, and oftentimes, we will do something with staging tables to stand in between the different systems. One drops off, one picks up, etc. The point is tremendously flexible, and there's many options for getting there. And then as far as the shop floor, I put this up there, that first bullet point that says feedback, more than just a plan. And that's what's important. You can come up with this plan and distribute it, but if you don't get any feedback from the shop floor to tweak it as you go through time, it's really just a plan until you replace that with a new plan. So that's why we find ourselves very often connecting with shop floor MES, taking updates from those systems and modifying the schedule accordingly as we go through time. So this is just a quick list of FAQs. There's a ton of more information on our website that you could go and you could dig into. And of course, we encourage you to talk to us directly, and we can address the specific issues that you're dealing with. Now, as far as Lean Scheduling International and who we are, just a couple quick slides on that. We have been doing this over 25 years. We've got a team, highly skilled team, and I think Chris kind of addressed that in the in the introduction. We have people who have been around this for a long, long time. So along with this, I would just, draw your attention to the fact that we do have a very big footprint in North America of all the companies out there that currently have Opcenter APS in them. We've got roughly, 80% of those companies are our customers. Beyond that, just one more point before we move into the demo phase of this, and that is I'm not going to go into these details, but wanted to point out that we do have a tried and true start to finish implementation process that we follow religiously with every implementation that we do. Everybody is on the same page. We all know, exactly what we're going to be doing, who's going to be doing it, and when, and what the expectations are for us and for you. So again, no more great detail on this, but understand that we do have a very, very tried and true methodology that we stick to for implementations. Okay, so I'm going to be turning it over to Fraser in a moment. And before I do, I just wanted to just give you a real quick preview of what he's going to be going through. He's going to do an introduction. He's going to talk a little bit and show you some tools for different kinds of what-if planning and modeling. He's going to get into some more complex scheduling, talk about labor and tooling, I imagine, with that as well. Shop floor integration, and then, you know, the connection to your purchase orders, to your supply, and being able to see all of that. Okay, so at this point, I'm going to pause and I will pass it off. But right. Chris, did you want to ask Ferg any questions at this point?
Yeah, I think it's a good place to pause, and thank you, Hans. As they're making the transition into the demo, we do want to give everyone an opportunity to ask any questions that you may have. As a reminder, you're able to do that either through the chat window or through the Q&A button at the bottom of your screen. I don't have any at this point. I do realize that there was a lot of information here that Hans covered at a very high level, but Fraser will definitely be getting more granular with it over the next half hour. So since there are no questions up until this point, I'm going to go ahead and, Fraser, turn it over to you.
Okay, thanks, Chris. Just confirmation, you can see the screen and you can hear me?
Yes.
Excellent. Okay,
yes.
Great. All right, so what I'm going to do, I have a couple of models here, different Opcenter models. I'm going to walk through most of the points that Hans mentioned. And what I'm going to do is start out with a plastics injection molding model and just look at a little bit about the supporting data under the hood, the kind of the Hans mentioned earlier on. So the whole point of every Opcenter model is to simulate your production floor. So the way we get to do that is grabbing as much data from your ERP system as possible, and basically things like the names of your machines. Obviously, this is a demo, so it's very simple. In this case, I've got some mixing machines, I have curing, I've got some extruders, and I got some packing lines at the end of some cooling areas. So these are simply the resources that we are going to load jobs onto. So this is where your capacity comes in. Each one of these machines actually will have a shift pattern associated with it, which tells Opcenter when the machine's available. And typically most machines are available 24/7 because they don't go home. But on top of that, we layer things like actual operators on top of those machines so that we can actually constrain it by when those operators are actually working. So we can combine our primary resources with our secondary fact that we have operators that need to be there to do the work. We have a concept in here of resource groups. You may know them as work centers. Basically what this is when I send an operation to the mixer group, Opcenter recognizes that I have a bunch of machines, and this gets into one of Hans' slides about how many different combinations there possibly could be. These 10 machines are available to do that operation. And we use this concept to create groups based on different sizes. If that happens, if these are tanks, for example, you create groups of 10,000 gallon tanks and groups of 5,000 gallon tanks, things like that. What Opcenter does is when I send an operation during the calculation of my schedule, in the background, it'll actually check each one of these machines in turn, and whether the fact that I have a person to run it, and is one machine faster than another, and all that kind of information. Is a machine currently working something for the next 3 days? All of that information goes into the final result, which is the best machine to choose at this time to get that job done the earliest. So the entire sequence of generating the entire production schedule is always looking for that optimum machine to maximize throughput and get things done as soon as possible. So that's my concept of groups, of work centers and groups. Then obviously, if this was a food model, the machine names would be different, but they're still resources, and that's how we can get into having different models for different industries. It's just basically these tables and these names. In this particular one, here are our products. Normally, we would download products from ERP for a demo. Obviously, I have them built in here. The products and routings, operation 10, 20, 30, 40. Inside each one of these, we'll have times, so time per item, setup times, anything else about this information that we want to keep. This model has a product family based on just a simple table attribute of what it is we're actually extruding. There's bins, tubes, and trays. So very simple stuff, but this allows us to get into more detail about that. Bill of materials is not here. Yeah, bill of materials is probably not there either. It's elsewhere. But we often will have, this one's very simple. We often will have into the model, which we would download from the ERP system, things like your raw materials, your purchase orders, and all that. And we'll get into that into one of the other models in a little bit. So that's how we would define, for example, a plastics injection molding system. Here is an electronics model. Go under the hood again. This time we'll take a look at the resources. Different machines. Okay, we have assembly areas where multiple people will actually be doing assembly of parts. So it's not necessarily, it doesn't have to be a machine, it can be an area. Products will be different, bill of materials, and this one does actually have that. So this particular part number here has a requirement of certain other parts. And then if I look further down, some of these have requirements of raw material parts. So you can build that whole bill of material structure from your ERP system, whether they're intermediate products or raw materials, and this system will schedule everything in the right sequence. So that's how essentially we can have one model or multiple models for different industries, yet all being the same Opcenter. And that chart that Hans showed with the core, that core is the same for all of these models. The outside layer is what we manipulate to have different industries and different looks and feels. So we'll jump into the actual schedule now. And again, this was that mixed machine, the extruders, plastic extruders, mixed machines are listed on the left. This is your typical Gantt chart, which we'll lay out here in a minute. We've got a KPI screen at the bottom, which I'm really going to focus on the on-time deliveries and the total setup times. We will go through, and the first thing I'm going to do is just do what an ERP system would do and sequence forwards by due date. And as soon as I do that, we'll load all the jobs onto the board. You see multiple lovely colors. Each one of these colors represents one of these bins, tubes, or trays, that product family. In between, when we change over from one product family to another, this little black block is representative of a setup time. So changeover in this model is incurred when I change my product family. And there could be more than one product family, but that's just the way this one is set up. If we look down at our KPIs now, you can see that this model is only showing me 66% setup on time, which is lousy. One of the reasons for that is because I only sequenced by due date, I missed this product family grouping. And that is giving me nearly 4,000 hours of setup time in this whole, 5 months of a schedule. So one of the things that the Opcenter gives you, again, because we're a simulation, this is not my final schedule. I can try different options. So one of the options I'm going to try is a wave, what we call a wave scheduling. And a wave scheduling is simply, I'm going to pick the product family, bins, and I'm going to sequence them forwards by due date, which is still okay. But now I've got only just that one product family. You can see, obviously, I have all red colors. So I don't have any setup time right now. Look at my setup time is 0 because they're all the same product family. Now I'm going to pick the next one, tubes. I'm going to sequence them forwards by due dates. You can see they're all grouped together. And if I zoom in a little bit, you can see that when I did actually change my product, I do now have setup time. So you can see my setup time has increased to 200 hours. And then finally, I'll choose the last option here and sequence them forwards by due date. They're grouped together. And now you can see that my setup time has increased. And basically what this means is I've got so many orders, I'm running out of space. I'm running out of capacity. So that's essentially, you can see the effect of building up based on a different way of scheduling. Another option we have built in is the ability to sequence by some APS rules and advanced rules. A preferred sequence is basically I'm going to say schedule by bins, tubes, trays in one pass. We'll let that run. See what that does for us. It's done almost the same thing. My setup time is increased just a little bit, still not very good. And then finally, I can do another what if, an APS rule called minimize overall setup. So I went from 3,000 hours or so, 3,800 hours. This one only cares about setup time. It doesn't care about due date whatsoever, because it just wants to constantly look for minimizing that setup time. You can see it's cranking away pretty well. And you can see how it's done. It's tried to keep the colors together, and it's dropped my setup time down to 2,200 hours. So the what if capability allows us to try different sequencing options and see what the effect is, so you're not stuck into just one sequence forwards by due date or anything like that. So that's just what if, which is one of the major advantages of an Opcenter, is the ability to run different schedules. I didn't commit any of those schedules to memory, to disk, essentially. So they're all still in memory. You can save multiple versions and choose the best one. And of course, one thing I didn't mention is you still do have the ability, if you really wanted to drag and drop. So you can actually bring jobs together like this if you really wanted to. Obviously, an ops model like this is too large for you to sit here and manually do anything. But that's the whole point of the algorithms. So I'll pause there. Chris, any questions before I move to the next one?
Yes, there are. There's actually two questions. One is more general in nature, and the other one is more specific to sequencing. I'm going to ask the first. The question is the core basically the same as 6 years ago? In other words, would a Preactor model I created 6 years ago still run with a little patch up?
Yeah, typically, if you had a model 6 years ago, you're probably running version 2012. We're currently up to, they changed the nomenclature, but now up to version 18. When you update that model, it does an upgrade procedure in SQL. The core, though, itself would still run exactly the same. It's basically the new version would add new capabilities. All the old stuff would still be there. So if you had a custom rule written back 5-6 years ago, we'd recompile that and test it. It'd probably be just the same, because the libraries don't really change that often. All the stuff on the outside, tables, events, anything that you created for that old version would run almost seamlessly.
Excellent. Another question here. Are there other built-in sequencing options?
Yes, good question. Under the sequence menu, now if you remember, Hans mentioned there's a family of products. There are actually 3 levels of Opcenter. There's a standard version, a professional version, and the ultimate version. The standard version has basically forward scheduling by priority, by reverse priority, so basically the same thing but backwards, by due date, which I've been playing, by sort order, which allows you actually to pre-sort the sequence that you send to Opcenter, so it schedules it in that method, or a weighted rule. And a weighted rule basically allows you to assign assign weights to certain features. Like this one, obviously due date is 100%, so you can make that 70%. You can put a table attribute, which might be my family. Actually, in this case, it's family, so you can update that one. Play with this, and then you have any attribute that you have defined in the model, you can apply a weight to. Once you set the weight, then you can go ahead and sequence. I have no idea what this is going to do, but we'll try it. We'll forward by weight, and it looked fairly decent. At least it put the jobs together. So that is the standard version. It has all of those. The professional version has these APS rules, and there's APS forwards, which is just a more compact forward sequencing, backwards parallel loading, preferred sequence, which I mentioned, overall setup, which I ran. There's a minimum width rule, and there's 1 or 2 other ones, built-in advanced planning and scheduling rules, which are optimized over the standard forwards and backwards stuff. Backwards options are all there. The ultimate version has all of those, has everything, plus the ability to create totally custom algorithms, which I'm going to demonstrate in the next model. That cover it all?
And there is one additional question that came in, and I'm pretty sure that we have this queued up at some point, but the question is, can one split jobs mid-sequence? In other words, a batch of 10 splits into 2 batches of 5 each, which can be individually manipulated.
Yes. There's a manual option to do that, which is a split batch. If it's something that needs to be automated, we can use the API to automate that. And the capability is totally there. And that obviously allows you to take a large job and split it over multiple machines for faster throughput.
Great. And that's all we have for now. So we're ready to move forward.
Great. Let me minimize, close this. So I mentioned the ultimate version has the ability to do totally customized scheduling algorithms. This one is a foods model, and we run into this often with ovens, okay? So if I just go ahead and sequence forwards by due date, standard stuff. If you're familiar with certain kinds of ovens, this right here is the ovens. You see how these jobs are staggered. Okay, so in fact, what's happening according to this simulation is you're sticking some stuff into an oven, you're waiting a couple hours, and you're opening the oven again, and you're stuffing some more stuff in it, and then you're opening the door again, you're opening the door again. Lots of ovens simply don't work that way. They simply, you open the door, you fill it with stuff, whether it's the same product or not, you shut the oven door, and you let it run till it's all finished. So essentially what you want is something like this, where they're all lined up nice and neatly. That way, okay? Obviously, you don't want to sit here as a scheduler and try and sit there and manually do all this because you'll never get it totally right. And there are times you can't, if you had too much coffee, your mouse moves and it doesn't work well. So what we actually do is create what's called an oven rule. And the oven rule, I'll just run it as I'm talking, if I can click the right button. The oven rule basically goes through, notices that you have jobs feeding into the oven and lines them up perfectly. And then it's basically, and you can see here, it took a little longer in the background because there's a lot more going on, but everything is now lined up. Essentially what it did, it recognized that I had jobs going into the ovens, realized that it had to wait until I had enough product to fill that oven, and then open the door one time and shove the stuff in inside. This can get very complex and very complicated with things like you don't want to wait too long for products to open the oven door. Sometimes you just say, okay, don't have enough product coming. I'm going to open the oven door and put stuff in. But all that information is typically what's known by the scheduler or the people that run the production floor. And we take that logic and we build it in using our API to create a custom scheduling rule so that things exactly sequence here in our model as they would actually look on the production floor. So that's one example there. I'll do one more. If I can find the right one. Is this the right one? It's fine. I got too many models open. It's hard to find the right one. That's ovens again. Okay, here we go. This particular model is a foods model, but we have allergens built into the model. I'll go ahead and schedule. First of all, I'll schedule this forwards by due date. Then I'll turn the picture over to the nut allergens, which we're simulating. So red is, yes, there's nut allergens, and green is, no, there's not. And there, so you can see how they're mixed a bunch of different lines. So I actually ran into this also in a chemical company where they're packing oils and lubricants, and they have to have the same types together. So the production people would spend hours in Excel coming up with this perfect production sequence, but then couldn't figure out how to back it into the upstream processes. So the way we deal with that in this version, again, a custom rule, is we do a pre-sequence. You see how it's sequencing everything together in groups based on, this case, we have no allergens, and yes, we do. And then we take that sequence and we apply it back into the upstream processes. And I broke this down into two rules just for demo purposes. And you can see now it's just basically going back through and building the upstream processes, which are shown here in black, based on that same sequence that we just built, we pre-sequenced in the packing. So this is the packing sequence that is nice and clean and only has one major changeover because it's got one allergen and is backward sequencing into the previous scheduling, the previous upstream operations. So basically just two examples of creating a custom algorithm based on the logic that typically you'd never get anything like this in an ERP system because the concepts simply aren't there. So any questions, Chris, at that point?
Yes, we have one question here, okay. And it's, How do you get a custom rule?
Okay, good. Yeah, I kind of mentioned it. It's the decision making of a custom rule typically comes from the guys on the floor or your current planners and schedulers that know how that sequence works. We take that logic and we use an Opcenter API to manipulate the sequence. So we basically, without getting too technical, we create a queue of all the operations and all the jobs. We know based on the logic how they want those to sequence. So we actually work through that queue, scheduling one order at a time with that logic that we extracted from the scheduler's head, so we can actually create the sequence the way they want it.
Excellent. That's all we have for now.
Okay. All right. I want to look at another constraint, which is, if I can find the right one again, is electronic. Yeah. Okay. So I want to use an electronics model here to demonstrate something, another constraint about labor. Most ERP systems, they might have actual labor in there, but they don't really assign them to jobs and constraint models because they run infinite capacity. In our models, we actually take labor. So in this case, I have diagnostic, it's an electronics model. I got some diagnostic tech people. Can't tell how many there are here, but there's a group of them. Same thing with QA personnel. However, I do only have 1, 2, 3 solder techs, some level 1 assembly ops, some level 2 assembly ops, and level 3 assembly ops. So that gives me the ability to create a group of these people, and the same concept as we saw in resources, the same concept of in this group of level 3 operators, I've got 5 people. And you could, and we have done, put actual people's names in there. So this could be like their scheduling certifications. You know, what level can they actually run jobs on? And that certification is assigned to, I believe, in the product information. Yep. So in the individual product routings, we're assigning what person needs to be available or needs to do it. So I mentioned earlier, the machine is our primary constraint. Now I have secondary constraints to levy on top of that. So if I go into my sequence and schedule, I will go ahead and sequence. I'll just do forwards by due date because it works easily for everybody. So this is now my sequence. And if I can highlight something, you can see everything. Everything is connected in the concept of these jobs. This is the routing. So we go from this operation down to this operation. You see I have a bunch of dotted lines. Those represent bill of materials or sequence or order dependencies. So if I click, actually I know this one here. This one here is based on a purchase order that came in on the 16th. So these orders are all connected by purchase orders or previous parts, etc. You also look down below, you can see I've got an actual plot of this. For example, I have 2 diagnostic techs, and I can actually see by dragging across what operations those diagnostic tech people are assigned to. Okay, so they're assigned to those jobs. If I take a look at my snapshot, you can see this one's better than that first one I mentioned. I drew 91% on time, 98 hours of setup time, so fairly decent. In the what if arena, we can also do things like, well, you can see that in this plot, I'm actually limited by 2 diagnostic techs because my plot is banging up against this red line. So one of the things I can do is I can disable that constraint, resequence, again, doing another what if, I'll use forward by due date again, and see, hey, if I actually did this, I can actually use more diagnostic techs. So it's giving me some information if someone said, do we need to hire somebody? But what effect does that have? If you look at my on-time percentage, it's jumped up to 96% from 91. So one of the other advantages of a system like this is you can do all kinds of simulation on whether it's labor. I could really use 4 or at least 3, at least 1 more person. Or you can say, well, if I look over here at this Haas machine, they're pretty well chock-a-block with stuff. What would happen if I wanted to buy another one? How much do they cost? How do I justify the cost of that Haas machine? Because I'm a simulation, I can simply go back to the data table, add another machine into that group, and reschedule and see what that does. And then that gives you some real-time data on what adding another machine, adding another person, and things like that can do. I mentioned this PO here, if I can find the right one again. We talked about having purchase orders and other information in the model. If a purchase order is late, what happens to my schedule? And this happens obviously all the time. The only requirement is we need somebody in the ERP system to update that, but I'll do it manually. So if I take this order and say, okay, that purchase order is actually not coming in until the 24th, so it's going to be delayed. You can see, first of all, the line went red to tell me I have a problem, which basically is saying these orders here, which are dependent on that PO, they're late. They're starting too early, because the purchase order is late. So, I can drag and drop to fix it, or I can simply run one of our tools called a schedule repair. And as soon as I click this, you'll see what happens. It just pushes those jobs that are dependent out so that they are now waiting for that particular purchase order to arrive. All the other downstream ops, if they were affected by this, which I don't look like there are any, they would have been pushed out as well. So my whole plan is now synchronized based on the fact that I've been notifying the PO is going to be late. The same thing would happen if the PO was early. I jumped to the last demo there, Chris. Is there any questions at all?
Yeah, the last thing that's kind of come through here is, what if we don't track POs? Can Opcenter tell us when to buy materials?
Oh, yeah, absolutely. As long as you have a bill of material that says, for example, in here, if in our bill of material information, it says that this particular work order, which is a module assembly, it requires that piece of information, whether I have a PO or not, I can still schedule it onto the board. And then we have a whole series of reports that we can run. There's a bomb shortage summary report, for example, that would tell me this PO is, in that report, it wouldn't exist. So it's just basically giving you almost like a buy schedule to support the model that I have, to support that production sequence. I need to make sure I have whatever that module is brought in by the 24th on this particular example. So yeah, I do have quite a few customers that don't put POs into the system, but they allow Opcenter to generate a purchase order buying schedule based on the schedule that they want to actually sequence. Okay, we're getting close on time. One last model to do. I want to jump back to the first one. This is that wave scheduling model. Remember, I scheduled everything forwards by due date, I think. When you import orders from a system, that typically does things like grabbing open orders, grabbing changed orders, and sometimes it will connect to an MES system and grab that data. I put that into separate download here just for demonstration purposes. We'll see if we can find out what that did. And I can't find out what that did, so I'll try it differently. Try that again. I had the order scheduled in the wrong way. Try that again. Doesn't work. I'll just show you what it should have done. Yeah, I can't see it. I must have their colors wrong. Inside the system, when we have a job, you'll see that this job is scheduled to start on the 21st at 2015. It's scheduled to end on 12/15. So that is my predicted schedule. We can also bring in, I did bring it in, statuses from an MES system, or sometimes an ERP system will have this, which basically says, as of 12/15, that's why it doesn't show up, you've made 250, and my quantity on this one is same, so I got some data problems on this model. But it gives me a status of how many I was supposed to make as of a certain time, or how many I have actually made as of a certain time, which then allows the system to recalculate that end time, the end time of the blocks, based on the predicted end time of the speeds that I should have run versus the predicted end time of what I'm now actually running. So if I should have made 100 by noon, but I've only made 10, I'm obviously way behind schedule, and Opcenter will actually extend this job out to, say, okay, if you're going to run at that speed, by the time you get done, you're going to be out here on the 24th. If you get another update from the MES, hey, now we're back on sequence, that job will shorten. And basically, it's giving you that real-time feedback into the system, so you can always come back into here, run one of these tools that we have called a schedule repair, and say, okay, I've taken inputs from my MES system. I want to repair that based on, if the job is ahead of schedule, behind schedule. If it's ahead of schedule, it'll make the job smaller, and then it will give you capacity where you can slide other jobs into. And that whole sequence of events it can be automated. We don't normally do this, manually, one thing at a time.
Very good.
Any questions on that one, Chris?
Well, as we have 2 minutes left, quickly, we have one last question here, and is shop floor reporting a part of Opcenter, or is that normally done in the ERP system?
As far as, reporting, you notice that I kind of brought out all this. Shop floor reporting, after it has been done, we can do it in here. We can show you what has happened after the fact. The actual reporting from shop floor into Opcenter is normally handled either by the ERP system or by an MES, shop floor data collection system. This system itself doesn't have that built in. I mean, we've built some tools to do that in a very simple way, but there are some much better tools out there as far as MES, like there's an Opcenter MES system that is separate from what you're seeing here, but will feed that data into here from the production floor.
Great. And again, Opcenter does have 32 standard reports that are built in. If we're talking about going to the shop floor, there are work to lists and all kinds of reports that come standard. But we also build custom reports or give you the access that, everything is in SQL. So you're able to do that on your end as well, whether it's through SSRS or whatever tools you have.
Right. Yep. And they're just SQL Server reports. So everybody knows how to do those these days.
Very good.
Okay.
And that is our last question. Hans, Fraser, we certainly appreciate what you put together for us today. Thank you all for joining us today. We hope you've been able to take away some valuable insight and information about the ways that Opcenter APS can benefit you, regardless of what industry you're in or what ERP system you use. If you have additional questions or would like to have more of a personalized demo, feel free to reach out to us by using the contact information now displayed on your screen. We're going to leave this screen up for another minute or so, but we'd love the opportunity to learn more about you and provide you with any additional information that you may need. You'll also notice the URL to our website on the screen as well. We encourage you to head over and check out our additional resources such as case studies and videos. You'll also be receiving an email following the close of this session with an opportunity to take a survey. We appreciate any feedback that you have about today. And lastly, we'll also be sending out a link to the recording of today's session. Again, if you have any further questions for us or would like to set up time to meet to discuss a little more in depth, you can reach out to us by the phone numbers or email addresses that you have there on your screen. Have a great rest of your day, and we look forward to connecting with you.